Hello, everyone. I hope everyone is doing well. Hope you learned a lot of information regarding the food chain and food web on the last video from Mr. Titus. This is Mr. Titus. And so I hope you're going to learn some more information, review. Um, even though we're not in school at the current time, you still can be reading books, doing your iReady, doing going on Clever, typing club, reading books. Like I said, learning more about reviewing your science information, watching videos, educational videos. So don't think this is just a time just to be wasted, but this is a time for you to recap and learn old information. So today we're going to talk about sound energy, and so I'm going to read a passage, short passage, and we're going to write down. You're going to get some pencil and paper. You're going to write down the questions and see if you can follow and see if you can answer those questions. Okay, so the title is called "The Sounds Around Us." Shh. Sit quietly for a few seconds. Pay attention to the sounds around you. What do you hear? Chances are, even if no one is in your classroom or in your house, someone is talking, you still hear the hum of the air vents, someone turning the page, or maybe footsteps in the hallway. No matter how quiet a room is, there are still sounds that we hear. Sound is everywhere in our environment. What is sound? Sound is a type of energy that travels in waves through matter, such as air or water. It starts when there is a movement of some kind. This can be a drum beat, a pencil tap, or a splash in the water. This movement creates a vibration of the air molecules. As the molecules vibrate, they knock into the next molecules and cause them to vibrate. This is similar to what happens when you drop a rock into still water. Ripples of water move out from where the rock was dropped. As these ripples in the water move out, they push against the water molecules next to them. The ripples are vibration in the water. These waves of vibration move out in all directions from the rock. In the same way, sound waves move out in all directions from the object that made the sound. We can hear many different types of sounds all around us. Sounds can be squeaky high or deep and low. Some sounds are loud, while others are barely a whisper. How something sounds depends on how the sound waves move. Pitch describes how high or low a sound is. A fast-moving sound wave makes a high pitch. A low pitch is made by sound waves moving slowly. A bird's high-pitched chirp has faster-moving sound waves than a cow's low-pitched moo. Volume describes how loud or quiet the sound wave is. Bigger sound waves like these made from an airplane push molecules very hard. This makes a loud sound. The noise is made by a ticking clock makes small sound waves. They push molecules more gently. So now on this page, you have a diagram with different sound waves in the different colors. You have the red one. The red says this sound wave is moving slowly. It has a lower pitch. Then you have the purple sound wave, which is this sound wave is moving quickly. It has a higher pitch. Then you have the green sound wave, color of the green sound wave. It said this sound wave is smaller. It moves a quieter sound. It makes a quieter sound, excuse me. And then you have the blue sound wave. This sound wave is bigger. It makes a louder sound. So now you have, I'm getting ready to start back reading. It says sound only happens when it has molecules to move. There is no sound in space because there are no air molecules in space. When an astronaut is outside the International Space Station using tools for repairs and upgrades, no sound is made as the tools bang on the station. Since there are no molecules to vibrate, there are no sound waves moving out. There is only silence in space. Have you tried to walk in a pool of water, you may have noticed that you cannot walk as quickly through water as you can through air. In the same way, sound travels at different speeds through different types of matter. While you can walk faster in air than you can in water, sound travels faster in water than in air. The speed of sound in air is about 768 miles per hour. Sound moves 4 times faster than water than air. Fighter jets can travel 1,550 miles per hour, which is twice the speed of sound. As soon as the jet flies faster than the speed of sound, it makes a sonic boom. A sonic boom happens when the sound waves made by a jet all crash into each other because the jet is moving faster than the sound waves. The older sound waves and newer sound waves pile up and create a shock wave. The boom sounds like a loud explosion in the sky. All right, so now let's go ahead. I need for everyone to grab pencil and paper. You can go ahead, pause the video now, but when you come back, unpause it so we can go ahead and read the questions. Welcome back. I hope everyone has their pencil and paper, and we're going to write the questions down. And so the direction, what's going to happen, I am going to read the question one by one, and then we're going to go back to the passage. And I want you to see if you can find the answers. I'm not going to tell you what the answers are. I'm only going to turn back to the slide or to the where the passage, and where in the passage the answer is going to be located. So question number 1, what is sound? What is sound? Number 2, how are sounds made? How are sounds made? Now remember, if you need to pause the video, you can pause it to see if you can find the answer. You need more time to find the answer. If not, you can continue to let the video play. Number 3, what is pitch? What is pitch? Number 4, how are different pitches made? How are different pitches made? Number 5, what is volume? What is volume? Number 6, what makes volume higher or lower? What makes volume higher or lower? Number 7, why is there no sound in space? Why is there no sound in space? Number 8, what is a sonic boom? What is a sonic boom? What is a sonic boom? All right, very good for those who are able to find the answers. If you have not been able to find the answers, you can roll the video back so you can try to read the passage you need to read again at your pace, or if you need to rewrite the questions. But what I'm going to do, I'm going to also, on the next slide, I am going to give us the answers to all of them so then we can make sure that we got the correct answer. So on the next slide, I am going to give you the answers to the questions. And like I said, this is not a grade. This is just an opportunity for us to review, for us to retain this information so then we can be ready whenever, if we ever have to learn this information over again, we will retain it because we knew it. So this is the slide with all the answers. I hope you learned something new. If I hope you were able to retain this information, and I'm glad that you are able to watch this video. Thank you again. This is Mr. Titus. Looking forward to hearing from you, hearing your voices. Bye bye.